In this video, we're going to talk about regular expressions. Now, a regular expression is a sequence of characters that defines a search pattern. So in short, if I wanted to find everything that started with an alphanumeric character and ended in the letters AT, I could find all the different matches in my data set. So this can be very useful for search and replace. Let's say I just wanted to change all those to dog. I could do that. It's also very helpful in cases for validation. Let's say you get an email address from a user and you want to make sure it could possibly be an email address. You can set up a pattern and figure out, yes, this could be an email address. If you like these videos, please like, share, and subscribe. It really helps me to continue making videos. Your help is greatly appreciated. So anyway, we are going to cover regular expressions in our Golang code. But to start off, we're going to go ahead and just look at them in just a regular text file using the replace box. So to open up this box, just go up to edit and go down to replace, or you can hit Control H if you're on Windows. And one thing to be aware of is this is not clicked at the start. So if I was going to put in the same thing before, it's just a literal search. So this is looking for a /WAT. So you have to click this use regular expression button right here. And this will change it to looking for those regular expression patterns as opposed to just looking for a literal string of characters. Anyway, we have several different characters that we can use. The dot is going to be any character, including new lines. Now, notice that we have quite a few different characters that we use in our regular expressions, and these we have to escape first. So if I want to find a literal period, I'm going to have to use a backslash and then a period, and then it pulls up all the periods. And if I want to search for letters, well, I just type them in how I see them. And notice that these have to be in order, like I'm pulling up cat here, but it's not pulling CAT here. Same way for digits. It's going to find whatever we put in there. It does have to be a match as well. Now, we have a whole bunch of different options here that we can use with the escape with the backslash first. Notice we have an uppercase and a lowercase option on a lot of these. For instance, /W is going to be any alphanumeric character. So it's a letter, it's a number. It's going to go ahead and highlight that. On the other hand, if I use the capitalized version, it's going to find everything that's not that. So it's going to find, all these different characters that are not letters, not numbers, spaces, new lines, all that business. So, and you're going to see this pattern throughout all these. For instance, if I want all the digits, /D. Now, if I change this to a capital D, it's going to find everything that's not a digit. Same thing for white space. We have our white space, and then capital S is everything that's not white space. And if we want our boundaries, we just put in /lowercase b. And if we want everything that's not a boundary, it's just going to be uppercase B. Now, if we want to find different things, but they don't have to necessarily be in a particular order, go M, C, I don't know, G. So if we put it inside the brackets, it's going to find any of those, and they don't necessarily have to be in order like when it was not inside the brackets. And if we want to find everything that's not those, we can just put our caret in the front inside of our brackets. And it's going to find everything except for, the M, the C, and of course the G's. And we can use this with a dash to find a range of characters. So it'd be A through M or D through M, whatever you want it to be. Likewise with numbers as well. Let's go 3 through 7. It pulls all those up. And let's look at repetition. So if I put in buzz, notice that it's just pulling up the first 3 as we would expect it to. Now, if I put in a repetition, let's say I want every one of them that's buzz that's 2. So it would pull up where it's a maximum of 2. And I could change that to 3 or to, or to 5. And we can even change this range where it doesn't have to just necessarily be like, hey, it has to have this many. We can put an upper bound and a lower bound. There we go. Must have at least 4 Z's, but cannot have more than 6. So let's put that back to 5. Oh, there we go. So we have 4, we have 5, and we have 5 here. It's not going to count this 6th one because we've set our upper bound at 5. And 0 or more repetitions. Okay, so let's... Now, this one says I can have one or the other. I could have, for instance, if I put this here, it's not just going to pull a T. I could have 0 or more. So I have 1 and then one A and then one T. But notice it's pulling the T's as well. It's saying I could have 0 A's, but it's going to go ahead and pull the T's as well. Now, if I use the plus sign, this one's going to be different. It's going to require that we have an A and a T. And of course, these have to be in that particular order. That's not gonna work. And we have our option characters. So we have hats here that's being recognized, but let's say we want to have hats as well. There we go. So this is just saying that the character that it's following is going to be optional. It could be hat, or if it has S, that's fine too. That's going to be optional, and so we're going to get a match whether it's hat or hats. And we have our start and our ends. And these can be very helpful. The more specific you are, the less likely you're going to pull in matches you didn't intend to pull in. There we go. We also have our ends as well, as you can see here. All right, capture groups. So a capture group is anything inside a parenthesis. So let's say I have my phone number here, and I no longer want these little dashes in between. So what I can do is I can create a capture group to capture the first 3 digits. I can create another capture group to capture the second 3 digits, and then I can create a third capture group to capture the final 4 digits. And then I'm just not going to return these dashes. So I can take my code here, my regular expression, I'll go ahead and put it up here, and grab my replace. And so what we're going to do here is we have our beginning align or end align. So we're just being very specific as possible to narrow things down. And here's our first capture group. So this capture group is going to catch what it has in there and return it to $1. So it's saying, hey, go ahead and capture everything that is a digit where there are 3 of them. So it's going to go ahead and capture the first set of 3. And then we're looking for, where there's a dash. And then, of course, our second capture group is going to catch any digits where there's 3 of them as well. And that's going to be returned to $2. And, of course, we have another dash. And our final capture group is looking for anything that's digits where there's a repetition of 4 of them. So it's going to capture the final 4. So we're just returning these 3 capture groups and, of course, leaving out whatever we don't want to return, which is the dash in this situation. So if we hit enter down in the replace box, it's going to go ahead and get rid of those dashes for us. And say if we wanted to turn it back, we just use our slightly different pattern here. And basically this pattern doesn't have those dashes anymore because remember we just took those out. And we're going to go ahead and capture the first 3 digits, the next 3 digits, and the final 4 digits. We're going to return those 3 capture groups, and we're just going to put our dash in there to put that dash back in. So if we hit enter 3 times. There we go. And capture all. So as you can remember, a dot captures any character, including new lines, but if I put this behind it, notice it's catching these lines where there are no characters. So that's going to capture everything in the document for us. And the OR operator. Let's look at our websites here. We have a .org, a .com, and a .gov. Let's say if I wanted to target all 3 of these, even though they're different, I could put in org, com, and gov. So notice it's going to go ahead and go for all 3 of those. Now, if I want to catch all the stuff in front of that, I just need to go ahead and put that into a capture group. So let's go ahead and put org, and gov. So I can take this, and this is targeting all 3 of these, and let's say I don't want to have the HTTPS anymore. Well, I can just create a capture group. Notice I have a capture group here. I'm going to go ahead and create another one. And the first one it comes across is going to be your first capture group, which is the only one we are interested in. So if I hit enter, I can get rid of the HTTPS : semicolon / and I can just replace it with this first return group here. And of course, we can change it back by just targeting our new match. So I'm just putting in what I want to add back in, and of course what's being returned by our group there. There we go. All right, let's go ahead and take a look at some Golang code. So we're going to be using the regular expression package, and looking at this, notice that we have a couple functions here, but mostly we're going to be using quite a few different methods. So as you can see, this regular expression here, it is a struct, but the most important part is just the access to all these different methods we're going to get access to. So just using the regular functions, we can use match or match string. Match is going to have a slice of byte taken in. Of course, we have a pattern for both, but this one's going to take in and search in through a slice of byte, where this one's going to search through a string. And both of these are going to return a bool saying, hey, I found that match, or I did not find that match. Now, if you take a look at both of these, they're going to say more complicated queries need to use compile and the full regular expression interface. So if you're using a very complex one, they're basically saying go ahead and compile it down. So we could use the regular expression package.compile to return a pointer to our regular expression struct, which has access to all these different functions here. So, and you can use the must compile. So if there's an error, it's gonna, your program's gonna stop if it doesn't compile. Anyway, you have a couple different ones here. You can create a copy, because notice this is the pointer. If you wanted to make changes to it without affecting the original, you can do that. We can find different things and find where they're at, where the start of their index, their starting index and ending index of something. You can have a whole slice of those. You got a bunch of different replace functions, so you can find something and then replace it. If you want to know what the original, regular expression, what that was compiled down, well, you can just use string, and it's going to return a string of what that regular expression is. There's quite a few of them here. We're not going to go through all of them, but anyway, let's go back to our code. All right, so we have our regular expression package with our match string function, and this is just going to take a pattern and it's going to go ahead and take a string. It's going to go ahead and look for that pattern in, and then it's going to return a bool. Now, this one's going to be very similar to regexp.Match. The only difference this one, they're both going to be looking to see if we find a match and return a bool telling us it found a match or not. Difference being is that this one is going to be searching through a string, where the other one's going to be searching through a slice of bytes. So if we go ahead and go run that. As you can see, both of those found a pattern that, yes, we did have, foo through there, and anything, behind it. And then the other one, of course, found, FO with alphanumeric characters before and after it. Now with this one down here, we're using the regular expression package in the compile function. So we're just going to go ahead and compile our pattern down here. And then that's going to give us access to those many different methods that we were talking about earlier. So as we can see when that printed, yes, there was our pattern, and we did not have an error, so it compiled down just fine. And here's our string, which we're going to be doing our searches on. So again, match string is going to be like the other one. It's going to return a bool, and it's just going to let us know if it found it or not. So for this first one here, it was just looking to see if it found any alphanumeric character, and then AT, and of course there's quite a few of them, in here. So that one returned true. Now, find, on the other hand, is going to return a slice of byte, and it's going to return what it found. So it returned that slice of byte that it found. So it did find a WAT, but we had to turn that slice of byte into a string so we could read it. And notice it just says bat here. So whenever you're using find instead of find all, it's just going to return the leftmost thing that it finds. So as we can see, we have find all here. Let's go ahead and raise this up a little bit. So find all returns a slice of everything that it finds. So any alphanumeric character that ended in AT, so bat, mat, sat, cat, rat, whatever. Notice it just didn't return, something here that didn't have an AT in it. So, and then we have our find index, which is going to tell us the index of the one that it finds. Now this is only returning one here. So as you can notice, our first one for bat is right at the beginning. So 0 to 3 are our indexes. So it just returns us here. But again, find all indexes is going to find all the indexes of all the matches. So as you can see, from 0 to 3, from 4 to 7, it's not going to find this one, but it's going to go 12 to 15 as well. As you can see, this one here was not a match. So obviously, it wasn't returned. And we had our match, which it was looking for an alphanumeric character in 18. Of course, yes, it found that as well, just like the regular expression package function that we were using up there above. Replace literal. So this one's going to go ahead and look for a match, and being that with our alphanumeric character and then AT, of course, it's going to go ahead and find a match, and for each one of those, we're going to go ahead and give it a slice of bytes of what we want it to change that to. So we changed that to dog. So every one of those which was a match, it just went ahead and changed it to dog, or whatever we want to put in there. Replace all, same thing. We're looking for that match, so we're passing in our source, which is what we're looking for, and what we want to replace it with, which was just cat. So it just replaced all of these again, except for it just didn't change the one that wasn't a match, that is left alone. And we have our string method, like we said, this just returns that regular expression that we compiled down. So, or any alphanumeric character, then A, and then T. So there is our regular expression. Now for this final one here, we're compiling a new regular expression, and we got a capture group here. And basically what we want to do is we want to go ahead and find image and then the number. We don't want to bother with this extension. We want to just go ahead and cut that off. So at the start of a line, we are looking for, here's our capture group. So we're looking for an IMG with a dash, which we have there. And then we're looking for a digit of 1 or more, which of course we have. And then we're leaving this section out here because we don't want to return this. So, remember backslash to find a literal period, and then PNG, and then end of line. So basically here, we're taking our replace all strings, and our source is this right here. So this is our string that we're going to be executing our match on. And if it finds that match, we're just going to go ahead and return that group. Being that we only have one control group, it's just going to be $1. So that returns, and then we print that off. So we're just printing off IMG, dash, and then our random number sequence. So again, we're just grabbing what we want to return and leaving out the stuff that we want to chop off. So in review, to play around with these and kind of learn them a little bit, just kind of easier just to open up a search and replace box and see, make sure that you click use the regular expression to see which things are a match and which things are not a match. Also found this regexp..com website. It's a pretty good website for running through some patterns just to kind of get used to them. But yeah, there's many different things that you can do with this in Golang. Like I said, if you create your own website, you're going to be wanting to validate things like an email address. You want to make sure that the password that they created, that everything qualifies, that it qualifies all of your standards for a safe password. So those can be really handy with that. Regular expressions may not be as fast as some of the built-in stuff that you can use in the Golang packages, but the flexibility that they give you is very strong. So there's just a wealth of benefit there. But anyway, if you like the video, please like, share, and subscribe. Hope you enjoyed it, and I'll see you in the next one.